Ferromatik Klockner induction device made in Germany is one of those devices enjoying a good mechanical and hydraulic design that is spoken for itself in industry year after year. Those who have worked with this device can simply tell you about its differences with other similar devices in respect of its manufacturing technology, and maybe it's a pity for them to do away with it. A wonderful and unique hydraulic and controlling system corresponding to the old years makes you have the good feel factor of such a design. Nowadays, a new generation of these devices is still manufactured in Ferromatik company. But is there still any hope for the technical services of the old devices available? This is perhaps a mind-boggling question for all those working with these devices. This is why the idea struck us to do something for its old controlling system. This way, we can have the peace of mind about its control parts and do something for finding out its faults, as well as reducing its stoppage time, while making it more accessible at the same time. The performance of its direct hydraulic and proportional valves are good. Thus, we can only design a control box to put it under our full control. We looked for the modern controlling systems trying to collect high-quality electric parts to safeguard the original design value. For the controlling system that is PLC, we use LS model made by LG company that has been active in the industry for many years. Likewise, to display data, enter information, and monitor the device. HMI made by LS was used. When designing the other box parts, we again gave the priority to the quality as our main standard. The control box was also designed based on the previously known parts as well as the user's friendliness. To keep safe the expensive parts, the necessary protections were built in. For example, on a way of all inputs to PLC, a suitable glass fuse was placed while the 24-volt hydraulic valves received their voltage from an interface relay between themselves and PLC to prevent PLC relay from being exposed to the ampere of direct valve. To save the expenses, we didn't change anything in proportional cards since they both work well and their troubleshooting and use are really easy. The electric map of this device is designed in such a way that it can detect the defects very quickly, with the help of labels on its parts and with that of the addresses and messages on HMI. Instead of its encoders, which are a bit old together with their difficult troubleshooting, we put two analog rectilinear displacement transistors which turn out to work efficiently with high accuracy while their troubleshooting and use were also easy. We changed the heating controlling system with a new generation of thermoregulators so that we could reach a fixed temperature, making it possible for it to link with PLC. By the way, if your device stops working and you probably can't fix it, you can. But the use of a telephone line and modem easily make it possible for the manufacturer of the control system from any place to be connected to the PLC finding the defect of the device. Now, let's get a bit more familiar with the control panel and the operator environment of the device. Here, there are the push buttons needed for the primary preparation of the device, such as the push button for turning on and off the engine and heater. Heater OK pilot light, alarm signal, alarm reset and buzzer, and 4 illuminated push buttons for 4 states which are adjustable: manual, semi-automatic, and automatic. The emergency switch is designed for emergency circumstances where it can easily be accessible. These 20 push buttons all together are set to move any mechanical parts of the device. You can use them to move the device itself. Of course, the settings of movements are done in HMI, which I'll tell you about later. This HMI is touchscreen, but we prefer to use the keys to protect its keyboard. Inside this HMI, there are different functional screens to show the state of the device, input and adjustment of the installed items. Some of them are fixed on all screens so the operator can observe its important items from any screen, such as the speed, the pressure of different parts, state of the mold, and injection. And also the heat of the heaters in the case of a link between thermoregulator and PLC. If you don't open the screen lock, you prevent accidental access to the screen options and nobody can change anything on the screen. For opening the lock, you should only click on it, entering the correct password. Help option can also be selected in all screens, being visible in any screen. The real estate of the mold and injection are shown in millimeter, which helps you both in production and setting. On the side and bottom strips, some keys are designed with the injection symbols, which you can click to enter the related screen. When you select each one of them, it is pressed showing as picked up. In addition, the name of the related screen is shown on the above corner on the right side. Here we try to set up the items which the operator really needs to change or see. Also, the initial states of the device are in a place easily visible for the operator. In the setting state that will be activated by this push button, you can do all the movements by pressing the related push button. To set the features of movement in this state, you can enter the values in the above screen. The bottom part of this screen is for the time that you enter a new mold and determine the state of the stage 1, 2, 3, mold open and mold close. In this screen, there are 4 stages for closing and there is 1 stage for clamping, where you can set the pressure, speed, state, and time features each. It is good to know that in the first stage, where you usually want to quickly close the mold and increase the device speed, ramp up and ramp down are programmed in a way that can softly and slowly move in the highest speed of the mold close state. Remember that if you don't set the right slope, that is, if there is too much slope interfering with the next stage, the alarm goes off. By using the method we introduced, you can set the mold close screen. In this screen, like mold close screen, you can set the features of pressure, speed, state of the mold in 3 stages, and you can have a high and monotonous speed by using its increase and decrease slope. Here, in addition to activating or inactivating the injector, you can also adjust the state of the injector, the number of injectors, reciprocation, the time between the two injectors, and the speed of the injector's reciprocation. In this screen, you can enter the features and values related to pneumatic ejector screen and activate or inactivate them. In this screen, you can also activate or inactivate core pollen and change the time of it. In this screen, you can activate the back injection unit and adjust it to move back after material intake of the injection unit and check the state of the sensor and the automatic and semi-automatic cycles. By the way, the delays of the front and back injection units are available for you. In the injection screen, the pressure, the speed, the state, and the time of each 4 injection stages and the features of material intake and suction are adjustable. There are some other 5 sections that have their own functions: file management, setting, outputs, inputs, and timers. Here, it is possible to save 16 recipe files. You can save your information for 16 different productions and open it whenever you need. It's only needed to put a name for it and choose a recipe number and save option, or if available, choose the open option. After opening the file and the above part, the recipe file and the name of the mode will appear, and in all screens you can watch the current file. For changing the screen lock, you can also come to this part and change it after entering the old password. In this screen, you can briefly check all the keys that you could activate or inactivate in different screens. You can also probably change them. In this screen, you can electrically check the accuracy of the push button function. You can simply press the push button, and if its light doesn't turn on, it means either the fuse or the push button is out of work. All the dates of the errors and states that we've defined under Solution times have been recorded in this screen and the supervisor can only delete them by entering the special password. In output screens, you can check the state of outputs. For example, if one part doesn't move, first check if the right command is given. In input screens, you can check the states and functions of inputs. Finally, in the timer screens, you can check the states of all timers which work in the fully and semi-automatic cycles and control the program.